I'm buzzing here with excitement to bring you what's next on the agenda. So now it's all about innovators and driving AI across diverse fields, and it's coming from places where technology is as big as tacos and tequila. So raising a toast to our friends from Mexico, now moving back to academicians, which are also really important. Universities, tech institutes are really important for the advance of AI. This is not a matter of private companies, it's a matter of academicians, entrepreneurs, governments. So let me introduce Jesus Palomino, which is our general manager of Guadalajara Design Center at Intel, which is located in Guadalajara, Jalisco, to moderate an excellent lineup of academics. Juan Alberto Ramirez Quintana from the Tech Institute of Chihuahua, Adrián Macías from the Tech Institute of Sonora, Mario Campos from Polytechnic University of Yucatan, and Joy Celine, a woman. We always have a woman in our sessions, of Autonomous University of Zacatecas. They are going to showcase the different fields which they are advocated to work and move forward with AI. Thank you.
So hello, everyone. We're very happy to have you here on this panel where we will be listening to very interesting projects that the Innovation Labs Network are pursuing related to artificial intelligence. So the Innovation Labs Network is an initiative among Intel and several universities of Mexico to foster technology development and innovation practices via learning, sharing, networking, and collaborating. We meet periodically to share perspective on technology areas to focus on, take workshops, learn from each other, and identify opportunities to collaborate. Each innovation lab has its own focus area and projects. One of the topics that we have been discussing in this network is artificial intelligence as a technology that impacts almost any area the labs are working on. So we're very proud to be the industry sponsor for this network, and we're very proud to see the progress that they are having. So thanks to all the presenters in this panel. And with that, we will start with a presentation of 4 projects that they want to share. So the first presentation is from Adrián Macías, a full-time research professor at the Institute of Technology of Sonora, ITSON, in the Department of Computing and Design. The name of the project is Development of a Wearable Technology for Users with Intellectual Disability. Adrián, welcome. What an interesting perspective on the use of technology to impact aspects of our lives. Please go ahead with your presentation.
Thank you. Good morning to everyone. We have been working on a project on Down syndrome children. This is our interest. We are really interested in solution in this area. Activity recognition has become an important tool to improve the quality of life of children, including those with disabilities. Automatic recognition of activities using multisensor data enables various applications such as child development monitoring, energy expenditures estimation, child obesity prevention, child safety in and around the home, and others. This is crucial for the future if we take into account an situation, for example, that children are moving towards sedentary lifestyles around the globe. This is a rise very important with the pandemic. So monitoring and stimulating physical exercise can be used to prevent obesity in children, for example. In children with disabilities, analysis of infant-object interaction has become an area of interest to identify behaviors associated with a potential problems such as stress, depression, inattention, among others. This is especially important in Mexico in people with Down syndrome. For example, researchers from Georgia Tech in the United States developed the Child's Play application. It's a tool designed to identify behaviors that occurs during child toys interaction, whose purpose is the identification of predictive behaviors of autism in young children. This application incorporates a series of augmented toys equipped with a BlueSense integrated wireless sensor package. The BlueSense sensors detect motion, sound, and touch via two analog audio input, two capacitive touch sensing inputs, and an onboard accelerometer to sense the child's interaction with each toy, along with a series of cameras to record videos of the application interaction, as shown in the presentation. Also, the application implements an inference module responsible for extracting features from the different sensors during the game without including video signals because of possible occlusion issues, and for the identification behavior from the extracted features. Using a component of pattern recognition implemented with diverse machine learning techniques, such as support vector machine, for example. The last element in this application is a graphical user interface used to show the video segments labeled with the identified behaviors. This application illustrates in a good manner the general application structure used by researchers in this area, which could be divided into three main components. As we can see in another application developed to the automatic assessment of problem behaviors in individuals with developmental disabilities. The general structure is first, sensing components are the first components used to obtain data from the subject and their environment. One or more sensing components of a diverse nature can be used, such as video cameras, sonic sensors, accelerometers, plus gyroscope, pressure, motion, bending sensor, RFID tags, and in general, any sensor required for the study, for the condition of the study. Second, it is important a mechanism for extracting characteristics from the sensed data that are then fed to an inference mechanism to identify activities or behaviors. Diversity of data sources pose challenges in the processing of signal for feature extraction and in the inference machine that could be implement algorithms based on neural network, decision tree, linearity, physiology, among others. And finally, is the information visualization component as a feedback mechanism directed to the researchers, to the user, to the therapist. It depends on the application. In this context, we are currently working on an augmented puzzle and augmented garments, a pair of embroidery gloves aimed at studying interaction between children with Down syndrome and their parents to identify actions that occur during play. The child plays the puzzle accompanied by her or his parent, and both use embroidered gloves during play. The game ends when the child puts the last piece on the puzzle board or when she or she decides to stop playing. In most cases, conventional analysis of behavior implies observing interactions in parent-child activities. The activities are based on particular objects like puzzles or in free play, where participants can show the preferred activity. In our case, we decide for the puzzle board. Currently, we are working on the implementation of the functional prototype. Thus far, we have carried out 2 studies. In the first one, a child with Down syndrome and their parents played with 3 traditional puzzles of different complexity from 9 to 21 pieces. This helped us understand the best size of the puzzle and also identify the different actions that take place during the parent-child interaction. when solving puzzles. This was a very important research for us. And second, we carried out an evaluation on game experience of the prototype using the Wizard of Oz technique. Children and parents each wore a pair of gloves. Results showed the children felt comfortable when using the gloves and solving the puzzle. That was a mind use if children could use or could wear gloves. Using the results, we created a puzzle composed by 3 physical components. First, a 5x4 puzzle board. Each location of the board contains force ID to encode the location and orientation of the pieces on the board. A set of metallic pins encode a binary number for each IDs. For example, in location 1-1 are encoded IDs 1, 2, 3, and 4, indicating the possible position of the piece in the board. We also implement 20 puzzle pieces equipped with an ESP32 processor powered by a LiPo battery. Each piece uses touch sensors to detect when the parent or child takes a piece, and MPU 6050 accelerometer plus gyroscope senses the movement, and to monitor the location and orientation, the board uses 7 digital input pins. In this case, a zero value means a piece is located off the board. This misses the zero value. Glove, the third component is glove for parents and children. 4 gloves are equipped with an ESP32 processor powered by a LiPo battery. Each glove is equipped with a flex sensor to detect when fingers are flexed, and with touch sensors to identify when the parent or child is in contact with a piece. Also, gloves are equipped with an MPU 6050 unit to detect hand movements. In the top, you can see the prototype of the gloves, and in the bottom, you can see the real implementation. So in the gloves, we already use it for another study, so you can check the marks of the use of the gloves. The puzzle is organized in 3 layers. The top one is responsible for the gathering of data from sensors, extraction of picture, and for the transformation in events. The middle layer is responsible for the transformation of those events into operations, and the bottom one in charge of processing operations to construct and identify each action. Using the puzzle, we expect to test the feasibility of identify operation. For example, the child takes a piece. The child is holding piece A, she'll place piece A on position 1, and then construct the actions that takes place. For example, child pick up piece A of the board and put it on the position 1, 1. The child picks piece B from position 2 and then put it off the board. Are the possibilities. This represents a great opportunity to develop inference mechanisms suitable for recognizing actions related to behavior when analyzing social interaction using augmented objects. In future work, we plan to use these actions and data from other sources to identify actions related to directive behaviors. We are interested in this type of behavior since they can significantly affect the child development from early childhood to adulthood. Our long-term goal is the construction of an application fed by these actions. I meant to make parents aware of their directive behavior in a suitable way. So this is my presentation. This is an important topic of research. Has not explored in what is has been little explored. So we think it's a great opportunity for working on. So thanks.
Thank you very much, Adrian, and thank you for your research focusing on how this technology can help families. We appreciate your research on this topic. Thank you very much. So let's move to the second presentation, and this is from Joyce Lozano from Universidad Autónoma de Zacatecas. She's a software developer at One Phase and an active collaborator in the LabSol software laboratory. The title of the presentation is Speed Bump Detection, a Time and Feature Selection Analysis. This is an interesting use of AI for our day-to-day dynamics as we move through the cities and the roads. Please go ahead, Joyce.
Well, hello everyone. My presentation is Speed Bump Detection at Time and Feature Selection Analysis. During this presentation, I will talk about introduction and a problem statement. In this case, I will talk about the context of the problematic that we are, the research is focused. After that, I will talk about the methodology that that we implement. This methodology has three sections: data collection, feature extraction, and simply time. And after that, I will talk about the feature selection. In this case, the feature selection, we implement or we use Galgo software. And finally, I will expose the result and conclusion that we have. First, we have a study by the United Nations, that indicates that around 55% of the world pollution lives in urban areas. United Nations estimate that 2050, around 68% of the population will live in cities. This means that the pollution is growing so fast. For this reason, it emerged smart city. What is a smart city? And smart city is ICT. Use ICT, that is Internet and communication technologies, and use Internet of Things and other things. These are used for a city to improve the decision making, improve the efficiency of the operation, and improve the provision of the urban services, and the city can be more competitiveness with another cities. How I say this increasing of the population is generating big problems. One of these problems is the accelerated deterioration of the road infrastructure. In Mexico, we have a big problem, that is the negligent use of authorities and the cities in control system. That is a growing problem. Why? Because in this case, in Mexico, is speed bumps, because many people in like a population and the authorities sometimes put a speed bump, put a speed bump on the road and on the road infrastructure, and they don't need to and they don't have problems if they put a speed bump because they want to put it in their place. Around 360,000 road traffic accidents in urban and suburban areas. One of the 3% of these are caused by a poor condition. We have a little problem because 3% is a little small amount of the accidents but data from INEGI we have problems because he can know how if the traffic accident was involved for a poor condition. And it's a reason that we want to use this type of monitoring to detect when a speed bump or a pothole is on the surface. General Assembly resolution say that if you reduce the number of the dates, if you want to reduce the number of the dates due to traffic accident, you need to have safer routes. It's a goal that General Assembly want to have. And for us, our goal is develop a methodology that allows monitoring and detecting abnormalities in the surface of the road. In this case, we're gonna detect speed bumps. In the future, we want to implement this methodology to integrate into an automatic system. And after that, this system can map all abnormalities in a virtual map. And this system also can generate virtual alerts when you was near for an abnormality. What was our methodology? Well, we have this device. This device is consists in a Raspberry Pi with a display and has connect MPU that has a accelerometer and a gyroscope. And another thing is has a GPS and has a button. This button helps us to tag the samples that we are passing on a speed bump. After that, the data that we collect from this device, we get data. We get information for Zacatecas, Mexico. We test that. We test that process here in Zacatecas. The information that we get was around 14,000 records. We test around 10 labs for the test, and the data the data that we collect was time, latitude, longitude, elevation, speed, the gyroscope. We have the 3 axes, X, Y, and Z. The accelerometer is the same. You have the 3 axes, and the trigger is the mark for the button when we have a speed bump. When we are using a genetic algorithm, we need to extract some statistic factor. This because we need to know how is the behavior of our data, and that's the reason we extract these statistics like mean, variance, neatness, kurtosis, standard deviation, maximum, dynamic range. These are the statistics that we extract for that data. Another thing is the sample time. We need to, when we are working with genetic algorithms, we need to split our data. And that's the reason that we need to split. We choose to split our data for the time. We split our data for 1 to 5 seconds. And how we can see in the table 2, if we split our data for 1 second, we reduce the size from the data for 14 1,000 record, we reduce this data for 1,400 records around. After that, well, for feature selection, as we can say it before, we use the Galgo software. Galgo is a package in R. R is a software language, programming language, sorry. This software implements a selection of multivariant features and based on genetic algorithms, and we use this algorithm, this software in the 5 records, in the 5 we use this software to test the 5 test data sets. After that, for each data set that we get, we use the 80% for training and 20% for test. And for the genetic algorithm, we make a setup of 5 features, and we develop around 200 generation. And another thing is we use a threefold cross validation strategy when we are working on the genetic algorithm. Finally, well, we get some results. The first is, as we said before, we have 5 types of data sets. And after that, when we test the model get for the genetic algorithm, we extract some performance measures for each of one. If we test the data set from the 1 second, we get a sensitivity and specificity, accuracy, train AUC, and test AUC. As we can see, for the 1 second is the best, we get the best performance because we has more precision for this, if we use this data set. One thing is for all of these data sets, we use logistic regression as a classification method, because when you work with a genetic algorithm, you need to use a classification method. And this is the reason because we use the logistic regression. Well, finally, the conclusion that we get for the research on this, we get that if we use the sampling of the 1 second, the classification process is really accurate, yeah. And our accuracy value, as we can saw in the last slide, we saw that we get a accurate value of the 0.98 accuracy. In a blind test, in accuracy, we get around the same value. Finally, what the result help to the result that we get, the genetic algorithms have a reliable performance for the type of anomaly detection strategy. In these cases, if we choose the genetic algorithm because when we start to get all the information for the sensors, like altitude from the accelerometer and gyroscope and all of these sensors, we have a lot of information, and the genetic algorithms help us to reduce this information and only work with the information that can help us to detect or to make a model can detect anomalies on the road. And yeah, I think it's all for me.
Thank you very much, Joyce, for your research on using these technologies for one of our daily dynamics in the urban areas. And with that, hopefully we make those areas smarter. Thank you very much. So the next presentation is from Juan Alberto Ramirez from the Instituto Tecnológico de Chihuahua. Juan Alberto is a PhD in electronics engineering and a professor at Tecnológico Nacional de México and Instituto Tecnológico de Chihuahua. The title of the presentation is Robotics PVR at Chihuahua. Thank you very much, Juan Alberto. Please go ahead.
Thank you very much. Okay, in this work, I present not one specific research developed in Chihuahua Institute of Technology. In this case, I'm talking about a review about robotic visual perception lab. Okay, this presentation, the content, I'm sorry, contenido. The content was who we are first, research projects, opportunities, and the future for each student that work in our laboratory. Who we are? First, we are a group of 4 researchers, which are Dr. Mario Ignacio Chacón Murguía, which he is the CEO of the laboratory, and Dr. Juan Alberto Ramirez Quintana, Dr. Javier Vega Pineda, and Master of Science Almadelia Corral. In our research, we have been developing 48 research projects for institutions and companies, 200 published papers for journals and proceedings, 2 books and 4 book chapters, 20 technological development, 82 theses completed at the level of Bachelor, Master of Science, and PhD degrees. And Dr. Mario Chacón is senior member in IEEE community. Okay, who we are? We are a laboratory in the Tecnológico of Chihuahua, where we develop research in different areas. The laboratory started in 1999 as a laboratory that in that moment, the objective was develop a artificial neural network and fuzzy logic algorithm for digital signal processing. But in the year of 2010, the laboratory changed its name to Robotic Visual Perception Laboratory. And since that time, we have been developed research in digital and signal processing, computer vision, machine and deep learning, neuro-inspired algorithms, data science, embedded system, and Internet of Things. And now I try to talk about some works that use that kind of technology. Our first project was, for example, detection and classification of cosmetic defects, which consist of use computer vision technology to try to find defects in some kinds of lens of Sophie company industry here in Chihuahua. And the research consists of develop the machine vision system, the vision system, and the Internet of Things technology to make a communication of the defect to the personnel of the Sophie. Another project was determination of quality of Chile, which was developed to a company here of Chihuahua that produced dried chili. And in that project, we developed a segmentation system that find the defects of the dried chili, and with this technology, the farmer can separate with the pneumatic systems the chili that has not the quality properties to be sold in the stores, and select the best dry chili for commercialization purposes. Another work was prostate image segmentation. We developed this work with the University of Windsor, and the objective was to have many two-dimensional images of the prostate, and with the computer vision algorithm, we reconstruct a three-dimensional image of the prostate. The objective was to develop a segmentation of the prostate of the man to find problems in the morphology of prostate, and to help the medical assistants or the medics of the to find tumors or abnormalities of the prostate. The next project is a set of algorithms that we published in IEEE, which consists of to determine the degree of dorsiness of a person. If you are driving and then you start to get sleep, then the algorithm detects the patterns of your eyelids, and then the algorithms make an alarm to know that you have a dorsiness problem, and then you must to stop the car. In this project, the main technology, the main objective was to develop algorithms. This is another work where we use computer vision to counting passengers in the buses of Chihuahua City. In that project was interesting because we started using an algorithm developed in Germany, but that algorithm doesn't work in the buses of Chihuahua, because in Germany the people are very disciplined. When they get to the bus, they get put in an ordered position. But here in Chihuahua, that algorithm failed because the people enter to the bus in a very crowded pattern, and then the algorithm from Germany failed. Then we start to develop our own algorithm to detect passengers in a regular bus here in regular autobus here in Chihuahua, and that was what was most of the challenge projects, because it was very difficult to count people in the regular buses here in Chihuahua. Another work that we developed with a PhD student that developed a research investigation in NASA was those torment detection. That project consists of find those torment that came from the Sahara Desert, and find a pattern that was used to predict where the dust can generate health problems. This project was developed with Pablo Rivas, who in that time was a PhD student of El Paso, and he was working in NASA. And actually the image that he used was from NASA. And we helped him to develop some algorithms to develop the prediction of where the dust of torments can cause health problems. Another work was thermographic analysis in cancer detection with a thermographic camera. We try to develop a system that find a health difference in the mammalian in the mammalian parts, and when the algorithm find an abnormality in the health, in the heat of the body, then the algorithm mark that heat difference to the objective to find the possible tumors. This is because the tumors generate an inefficient absorption of nutrients, and that inefficient absorption generate more heat in that part of the body. That system was used just to auxiliar the technician, but not has diagnosis tool. Another project was agricultural crop analysis, which consists of find with hyperspectral images taken from a drone the quality of the drop for farmers. For example, we could found with that project the quality of the soil, the humid condition, temperature condition, part radiation condition, and with that information, we inform to the farmers if the conditions were the appropriate to develop the regular work in the soil. The next project was human gait analysis. That project was developed to analyze the gait patterns of a person, and with some points of the legs, we develop different signals, and with that signals, we develop digital signal processing using some neural networks, and with that work, we could find if the person present an abnormality in its gait. And with that project, we developed a CONACYT project with the CAM centers of Chihuahua, which are centers that with their objective is to educate persons with cerebral palsies. And we developed that, we implement that algorithms with that system that use the Kinect to develop a therapy. Then the kid with cerebral palsy see an scenario, and with the Kinect, sorry, the kid develop a therapy. For example, I have here a video. What's the video? Another work was motion analysis to Cladocera. Cladocera is a kind of organism that was used to measure the toxicity of some medicines. Other work is motion detection with embedded machine learning, in which we use machine learning techniques as neural networks, convolutional neural networks to detect motion. Another works is brain-computer interfaces. We use the emotive insight mindwave MUSE an OpenBCI technology to develop algorithms for BCI technology. And with that, we developed system to communication using the eyelid for disabled people. Another work was motor imagery, where the person imagined a motion of the arms and the legs to the objective that the brain generates some signals to control, for example, a prosthesis. The another work is to recognize parasites and using data science, a database that we have been developing with the Chihuahua University, in which we first developed the structure for a data science information using the University of Chihuahua, and we are creating the ground truth, the metrics, and after that, we have been developing the deep learning methods to detect some organisms in these samples. Other work is object tracking using deep learning networks. Other big work that now we are developed is our own deep learning methods. We don't use the classical Google Net, ResNet, and something like that. We are developing our own models of deep learning according to the problem that we found in the media, literature, or the companies that try to work with us. Another work that we are developing now is image complexity study. And well, our students had many opportunities to work in many academic positions in national, international places. Our students published their papers in many international congress. For example, here is Pablo when he started to work in NASA. And our student work in companies like Visteon, Bosch, Delphi, Honeywell, Intel, etc. Or in research and universities. Okay, and thank you very much. Sorry for the bad using of the time. And that's it for my part.
Thank you very much, Juan Alberto, for sharing the vast research that your lab is doing. Thank you very much. It was very informative, and congratulations on all your progress. The last presentation, excuse me?
Well, this presentation is to share our work and try to get more collaboration for our laboratory.
Correct. That's the spirit of the Innovation Lab Network. Thank you very much for sharing. So the last presentation is from Mario Campos Soberanis from the Universidad Politécnica de Yucatán. He's a master in computer science and has worked as a chief technology officer and software developer and architect in public and private industry, specialized in web development as well as artificial intelligence products. The name of the presentation is Improving a Conversational Speech Recognition System using Phonetic and Neural Transcript Correction. Thank you very much, Mario, for preparing this presentation. Please go ahead.
Well, thank you, everyone. My name is Mario Campos Soberanis, and I'm really happy to share with you this work. It's called Improving a Conversational Speech Recognition System using Phonetic and Neural Transcript Correction. This work was presented in the Mexican International Conference on Artificial Intelligence 2 weeks ago, 2021. My co-workers here are Diego Campos Sobrino and Rafael Miana Cámara. Okay. First of all, I want to talk with you and share you why we think this is an important research field. I also work in a company that's called Soldai, and we work a lot with automatic agents and telephonic sales systems, okay? We have some telephonic sales system that is running for a large bottling company here in Mexico, selling beverage in Spanish. But often we can see that the product names are out of vocabulary words. So traditionally, automatic speech recognition system, those systems that translate speech to text, have really bad time trying to figure out what these words that are not part of the regular Spanish vocabulary. So we need a way to train or to perform a fine tune on those models. And often the best ones are the shared by the industry, like Google, AWS, or IBM, but still a lack of strategies to fine tune these models. Okay. There exists a lot of research about separate components in automatic speech recognition systems, and also in natural language understanding entity recognition. This is a task when we are detecting specific entities being mentioned, for example, a product in a telephonic sales systems. So in this paper, we propose an architecture to implement conversational systems incorporating an ASR transcript correction component to enhance the recognition of the named entity in telephonic sales systems. Okay, we use a transcript correction component with a hybrid strategy. It uses a phonetic correction and then a neural verification, we can say about. This architecture is currently being used for a large bottling company to take telephonic orders. Okay, so the method is like this. We record the audio using the PBX technology. We use Asterisk, and we use the Google ASR automatic speech recognition system. We get the transcript, and after that, we apply a phonetic correction algorithm. This takes into account the context. The context are these out of vocabulary words that need to be recognized by the system, and these parameters of the original transcript and the correction pass through a neural network component. Okay. So there have been a lot of work around this, different strategies to make this, like RNN transducer, and also there have been proposals about phonetic and hybrid correction strategies. But the effect on the natural language understanding entity recognition task have not been reported until now. So this is the system implementation. Okay, we have different components. The client calls to a PBX component. Asterisk in this case is in charge to manage all the telephonic communication. We have a custom state machine that controls the different states in the conversation, and is in charge to verify what action is the client doing. Okay. After that, this is sent to the automatic speech recognition module. Google, we are using the Google speech-to-text API. And the component in green is the one that we are implementing here. We use a post-correction module to correct the errors that the automatic speech recognition of Google can have. And after that, a correction decider implemented using a long short-term memory neural network is applied. Okay, we understand what the user is trying to say using a proprietary natural language understanding engine developed by Soldai. It's called Hermes. So the correction is using both strategies, a phonetic correction algorithm, and after that, the corrections are evaluated by a LSTM neural network. Okay. Why we choose this phonetic correction algorithm? Because it runs in polynomial time. And this is important because we are interacting in real time with users via a phone call. So we cannot use a huge transformer model that is going to take a lot of time, but instead we need a better way to do it. This algorithm transforms ASR transcripts to phonetic representations and compares segments of the transcript with phonetic representations using either International Phonetic Alphabet or WBET. Okay, so the phonetic correction algorithm takes an input of the ASR transcript, the content or the AOB words that are going to be generated, and outputs a correction hypothesis. After that, we use a neural classifier to verify if this correction should be done. What's the problem here? A hyperparameter of the phonetic correction is the correction threshold. If this threshold is not set to the right configuration, this algorithm can perform overly aggressive corrections and then damage the ASR transcript. So the neural network acts like a kind of regularizer for this algorithm. This net was done to be robust for text detection. We have an embedding layer, then an LSTM layer, and finally we output 0 or 1 depending on the correction. Enhance the transcription or it doesn't. We perform the standard preprocessing, symbol and punctuation removal, key normalization, etc. And here is our experimentation methodology. We recorded 640 recorded audio. After that, we apply different phonetic correction variants, and we get some correction hypotheses. Okay, we are talking about 46,000 order. We compute the word, where is the word error rate. It's a metric that comes really useful to examine if the result of a speech to text is good or not. Basically, is telling us how many words the system didn't recognize. Okay, so we label examples depending on the where it's enhanced or not. If it is enhanced, the correction should be done. If not, it should not be done. Okay, we split our training data in training, validation, and test. And after that, we pass the results to the LSTM, and from that to the natural language understanding engine, okay, to extract the entities. Here, we are measuring if we are capturing more products using this strategy than without this. We measure the extracted entities against the ground truth using the Jaccard distance, and then we get the final metrics. Okay, so results we have the evaluation metrics on the test set in the neural component show a high macro-average score. This kinds of indicates an overkill with the LSTM. It make a really good work. And here we can see the standard word error rate. The ASR output was of 0.29, and with the phonetic correction algorithm, we enhance a relative word error rate of 30% of the sentences when the ASR commits some errors. And using both the phonetic correction and the neural decider, we enhance 39% of the relative amount of phrases. Okay, we achieved 0.18 word here. The immediate recognition task, here we are showing the average results of the phonetic correction algorithm and the hybrid correction. Okay, and as you can see, the precision of the phonetic correction is bad, because for bad thresholds, for large thresholds, we make bad corrections, and that affects the precision. However, you can see that using the hybrid methodology, we retain almost all the precision that we have in the original ASR. but also we are enhancing the recall. So in the overall result, we are enhancing the F1 score. Okay. Here we can see the comparison against the baseline is the automatic speech recognition system. In red, we see the phonetic correction algorithm by its own. And in the blue line, we can see the hybrid classifier. Okay. As you can see, around 0.2, both the phonetic correction and the neural classifier perform better than the baseline. However, you can see a quick degradation for thresholds up to 0.4 in the phonetic correction algorithm. But the classifier still tries to maintain the precision. Okay. The recall on both architectures are better than the baseline ASR. That's expected because we are enhancing the original ASR transcript. And here we can see the enhance in the F1 score on the NER task. This means that we are capturing more products and we are reducing the number of interactions with the end user, so it can lead to really good results. Okay. So the phonetic correction algorithm by its own incremented recall will show bad precision results for high correction thresholds. The implemented neural achieved a good F1 score, 0.98. LSTM network acts as a regularizer for the phonetic correction method, avoiding overly aggressive corrections. This hybrid algorithm can reduce the relative wear in 39% of the phrases, and the method exhibits an improvement on the NER task F1 score from 0.85 to 0.91. We want to propose different architectures for future research and validate the results on different application domains. Okay, compare this method against end-to-end algorithms. Finally, we share a lot of our research and work in the page on our blog. You can check it out if you are interested. And thank you. That's all for me.
Thank you very much, Mario, for your presentation on research to enhance such systems. We appreciate it. So with that, we are done with the presentations. Thank you all for your presentations. We really appreciate the sharing of your projects so that all of us can learn about what is going on at the universities that are part of this Innovation Labs network. What an interesting set of presentations with technologies related to artificial intelligence impacting a variety of areas. And this is just an example of the impact artificial intelligence can have in many aspects of our lives. Thank you for your work on that, for your sharing. And with that, we are done and have a great day. Thank you.
Oh, that was a great session, truly inspiring. Gracias, Mexico.